Hello everyone and welcome to the first lecture of our four-part lecture series. In this lecture we'll be discussing about fundamental aerodynamics. Now in this lecture series we'll be talking about aircrafts and the science behind their flight. So without any further ado, let's take a look at a basic overview of this lecture series. Like I told you, this lecture series consists of four separate lectures. On the first day, that is today, we'll be discussing about fundamental aerodynamics. On the second day, we'll talk about aircraft engines and power systems. On the third day, we'll discuss about aircraft stability and flight controls. And on the fourth and final day, we'll discuss about the theory of propellers. So without any further ado, let's talk about the fundamental aerodynamics. Okay, so if this word aerodynamics is a new word to you, aerodynamics simply refers to the study of the interactions of a moving fluid with the solid which is moving through that fluid. So this is what we'll be talking about today. Now, since we're discussing about aircrafts, we need to have a basic idea about the forces which act on an aircraft. So there are principally four main forces which act on an aircraft. They are namely thrust, lift, drag, and weight. So let's talk about these forces individually, shall we? Now thrust is basically defined as the force which pushes a plane forward. It acts in the forward direction. And thrust is supplied by the engines of an aircraft. How this thrust is provided by the engines will be discussed on our second lecture, which will be on aircraft engines and power systems. But for now, just remember that thrust is the force which pushes the aircraft forward, as shown. Fine, now the second force, which is lift. Now just like thrust pulls the aircraft forward, lift pulls the plane upwards. Now lift is generated by the part of the plane called the wing. Now the wing can generate lift because of a very important physical principle called the Bernoulli principle. The wing can use this because of a very special shape which it possesses. This shape is called the aerofoil or airfoil, depending on whether you prefer British or American English. Anyway, we'll discuss about the aerofoil and how the wing generates lifts later. But for now, just remember that lift pulls the plane upwards. Now the third force, which is drag. Now drag is a wee bit different from lift and thrust. So pay attention. Now drag is defined as the force which tries to impede the movement of an aircraft. What does that mean? This means that drag basically tries to slow the aircraft down. Have you ever tried to run with an extended umbrella behind you? It's pretty hard. The faster you run, you feel that there's a force which is pulling you backwards. So this is drag. You may also observe that when you run faster, that force is also greater. So similarly, when the aircraft is not moving at all, when it's parked on the ground, it doesn't experience any drag. But when it's moving faster and faster, the drag force which is acting opposing the movement of the aircraft will increase. So take a look at this aircraft. And one more thing, drag is created by air friction. So if you take the plane to a place where there's no air at all, then there won't be any drag on the aircraft no matter how fast it flies. Right, so take a look at this picture. So drag acts to oppose the motion of the aircraft, so it always acts in the direction opposite to the direction of motion. In this case, it's backwards. Okay, now the last force, which is weight. Weight is defined, we all know what weight is. Now weight is the force which tries to pull the aircraft towards the earth or the ground. We all have a weight. The weight is created by the gravity of the earth. Now if you take the plane, basically if you take an object or the plane to a place where there's no gravitational field, say somewhere deep in space, then that object or the plane in this case won't have any weight. But since we are living on the earth and since earth has quite a strong gravitational field, and since all aircrafts fly within the earth's atmosphere, we need to think about weight when we are discussing about aircrafts. Okay, So those are the four forces. Now remember that weight pulls the aircraft downwards, just like lift pulls it upwards. It pulls it down towards the earth. Right, so those are the four main forces of an aircraft. Let's just take a look at this slide so you guys can get a basic overview of these forces. So like I told you, there are four forces: thrust, lift, drag, and weight. It's usually pronounced in that order. Thrust tries to pull the plane forward, drag tries to slow it down, lift tries to pull the plane upwards, and weight tries to bring it down. So these are the four forces. Right, that being said, let's take a look at the structure of an aircraft. Okay, so I have a picture, and I'm going to show you a picture in this slide. But before I show it to you, just recall an image of an aircraft which you might have seen, right, recently perhaps. And think of the various parts that you might have observed, and think of the parts which are striking, which have been retained in your mind. Just think about that. With that in mind, take a look at this picture. Right, okay. So we have many parts. So there's a part called the propeller, there's a part called the fuselage, then we have a landing gear, flaps, ailerons, wings. Then there's another part called the vertical stabilizer, a horizontal stabilizer, an elevator, and a rudder. Alright, so if you don't know what these parts are, it's perfectly fine. We're still at the beginning of this lecture series. But by the end of this lecture series, you guys will know exactly what each of the parts are, and the part and the function that they play in assisting the flight of the aircraft. So basically, the structure of a plane can be categorized into 5 separate components. Basically, the fuselage, the wing, the empennage. Now, the empennage is a collective term. We'll get to that in a minute. The power system and the landing gear. We'll be discussing about these individually. First, let's talk about the fuselage. Now, the fuselage is basically the body of the plane, which holds the entire structure together. So, if a person says the body of the plane, they actually mean the fuselage. Now, the fuselage holds various components of the plane. It holds the landing gears, it holds the wings to the empennage, it even holds you if you're going on a vacation. So, basically, the fuselage can be considered as the connecting part. It connects everything together. It connects the engines, it connects the wings, it connects the empennage, it connects everything, right? So in commercial aircrafts, the fuselage holds passengers, cargo, the cockpit, and even the landing gears. Right, with that being said, that's enough we discussed about the fuselage. We'll talk about the wing. Now the wing is, I'm pretty sure all of you guys might have seen what wing is. I told you that the wing can generate lift because of a very special shape that it possesses, and I told you that this shape is called an aerofoil. So take a look at the bottom right hand corner. The bottom right hand corner, you can see that there's an aerofoil. That's the shape you'll get if you cut a wing and see its cross section. So this is what it looks like. Now this type of aerofoil is called a flat bottom aerofoil. That's why it's labeled as flat bottomed. So this is the shape which will cause lift. We'll talk about that in a few more slides. But for now, let's just talk about the basic parts of the wing. Now, the front edge of the wing is defined as the leading edge, and the backward edge of the wing is defined as the trailing edge. If you join the leading edge through the trailing edge by a line, this line is called the chord line. Okay? So remember these terms. The leading edge, the trailing edge, and the line joining the leading edge to the trailing edge is called the chord line. Right. So that being said, let's take a look at camber. Now, camber is basically a way of exhibiting the asymmetry of an aerofoil. So take a look. Now I have got 2 aerofoils here. Let's take a look at the first aerofoil. If you draw the chord line, remember the chord line is the line which joins the leading edge to the trailing edge, which will look something like this. You can see that the areas above and below the chord line are symmetrical. They are almost the same. Okay. But if you take a look at the second aerofoil and you draw the chord line, then you can see that there's more area above the chord line than below. right? So this is called a cambered aerofoil. It's not a symmetrical aerofoil. Okay? Right. Now let's talk about how a wing works. So essentially the wing works like this. Now when the plane is moving, air comes and hits on the wing. And part of the air moves above the wing and part of the air moves below the wing. Because of this very special shape that the wing possesses, called aerofoil, the distance that the airflow moving above the wing needs to move is greater than the distance the airflow moving below the wing has to move. So basically, if we call this distance as d2 and the distance below as d1, d2 is greater than d1. Okay? So this means within the same time interval, the airflow which is moving above the wing needs to move a greater distance than the airflow below the wing. Now we learned about this equation in fundamental physics, which is speed equals distance divided by time. So if the airflow above the wing needs to move a greater distance, which is d2, in the same time, that means that the airflow moving above the wing needs to move faster than the airflow which is moving below the wing. So because of that, the airflow moving above the wing must move faster. And the Bernoulli concept, states that when the speed increases, the pressure decreases. Okay. Now remember that the airflow moving above the wing moves faster, right? We know that. So this means that the air on top of the wing has a less pressure. So because of this, there's a lower pressure on top of the wing and a higher pressure below them. So now we can consider pressure as a force, because basically pressure is force per unit area. So because of that, there's a higher force per unit area below the wing and a lower force per unit area above the wing. So because of this, there's a net force acting in the upward direction, and this force is called lift. Right, okay. So this is a simple way to explain how the wing works. But if you want to know the complete Bernoulli concept, because the Bernoulli principle is actually an equation, it's a concept, it's an energy concept. So if you want to learn that completely along with the derivation of the formula, check out my other video. But this is just a basic overview of it, so you guys can understand it simply. Right, with that being said, let's talk about the angle of attack. Now, angle of attack is something like this. It's the angle between the chord line and the relative airflow. If you take a look at the wing, the airfoil in front of the airfoil, the airfoil which is on your left hand side is the wing, and the one on the right hand side is the horizontal stabilizer. So if you take a look at the wing, it's not horizontal. There's a small angle. Now this angle in this case is around 7 degrees. This angle, or the angle made between the chord line and the relative airflow, is called the angle of attack. Now relative airflow is essentially the name given to the airflow which is undisturbed by the airfoil. So basically, the angle of attack, now angle of attack is like this. So when an airflow comes and it breaks at the airfoil, one moves above and one moves below. This is in a case where the angle of attack is 0. Now let's increase the angle of attack, shall we? Like that. So still, if the angle of attack is maintained within a proper limit, the airflow will move just as it did before. But if that limit is exceeded, we'll encounter a very dangerous phenomenon called a stall. Okay, now stall is a new term for you guys. Now stall is essentially something which occurs when the airflow tears itself apart from the airfoil and moves straight without following the path of the airfoil. This means that there won't be any lift and the plane will basically fall from the sky. So let's take a look at this. Now in this case, the angle of attack is 0. right? And wind comes and hits on the airfoil. One part moves above and one part moves below. That's perfectly fine. That's what we discussed about. And now we're going to increase the angle of attack. We keep on increasing it, and a bit more, and somewhere like there. Perfect. So at an angle of around 15 to 16 degrees for a slow flying aircraft, we'll experience a stall. Now this is what happens in case of a stall. Now the bottom, the airflow which is moving below the airfoil will move perfectly fine, but the airflow moving above the airfoil will tear itself apart from the airfoil. So because of that, none of the concepts we talked about are valid. Then D2 greater than D1, that's also not valid. Then there's no reason for the airflow to move faster above the airfoil and slower below. So therefore there's no change in pressure, leading to no force, no lift. And because of that, the plane will basically fall. Right? So one more thing to note is that the angle of 15 to 16 degrees will give a maximum lift also. Right? Because when the angle of attack increases, the lift also increases. We'll discuss about how this happens in a later episode. But for now, just remember that when the angle of attack increases, the lift increases. This is the very reason why we keep an angle of attack. So at 15 or 16 degrees, we get a maximum lift. But just after that, it's followed by a stall. A complete nullification of lift, or basically complete complete disappearance of lift. And when the angle exceeds around 16 degrees, the wing will stall and fall. Right. So let's take a look at this graph. So say that you want to design an aircraft, and when you want to design the wing and you want to buy an airfoil. When you buy an airfoil, or with any airfoil that you purchase, you'll get this graph. Now this graph will show the performance or the lift generated by the airfoil at various angles of attack. So on the x-axis you can see the angle of attack, on the y-axis you can see the coefficient of lift. Now coefficient of lift isn't exactly lift, but for now just think of it like lift, okay? We'll discuss about what exactly coefficient of lift is and the equation which relates coefficient of lift to lift in a later episode, right? So here you can see several graphs, but we'll be talking about the red graph, okay? Now the various graphs are given for various values of the various Reynolds numbers. We'll discuss about that later. But for now, just think about the red color graph, okay? So here you can see that at around 14 degrees, you can get a maximum coefficient of lift, which will translate to maximum lift. But take a look at the graph near 16, 17, 18, 19, around 19, between 19 and 20, you can see that the graph suddenly disappears. This means that there won't be any lift after that point, meaning that that is the stalling angle. So we can't exactly describe with this graph, so hang on, we definitely need a better sketch for that. Right, okay, with this, you can see that when the angle of attack is 0, you have a coefficient of lift of around 0.6, I suppose. A bit more than 0.5, sorry. And when the angle of attack continuously increases, the coefficient of lift increases, and we have a maximum coefficient of lift at an angle of around 17, I suppose. Yes, around 17 degrees, you have a maximum coefficient of lift. But at 25 degrees, it's completely off. There's no lift, meaning the stall. So remember that I told you in the previous slide that a stall occurs at around 15 or 16 degrees, but this one is 25 degrees, right? You can ask me that question. But basically it varies according to the plane and also according to the Reynolds number. So we'll discuss about that later. But basically the idea you need to get is that when the angle of attack increases beyond a certain point, a stall will occur. Now, there are two types of stalls, a high speed stall and a low speed stall, but this is called a low speed stall, okay? We'll talk about the other part later. Right, now the critical angle of attack. Now, critical angle of attack is basically the maximum angle of attack you can get without encountering a stall. So take a look at this. The critical angle of attack would be 25 degrees. It's the angle just before the stall. So if you want to take a look at the airflow and how it varies with the angle of attack, take a look at this picture. Now at 0 degrees, there's very little turbulence. At 5 degrees, a little more. 16 degrees, you get maximum lift. And which is the stall angle, basically. It's defined as stall angle. So if you increase it more than that, you can see that the airflow basically separates from the wing. Now the ones shown in curves is basically the turbulence. So we don't consider that. Okay. So basically at 20 degrees for this airfoil, the airflow will separate itself from the wing. Okay. That being said, we can go to the second part, the third main component of the body of the airplane, which is the empennage. Right. So the empennage is basically a collective term for the rear section of the aircraft. Now the empennage consists of four main parts: the horizontal stabilizer, the vertical stabilizer, the rudder, and the elevator. Okay. So there are various mechanisms which are used inside the aircraft to maintain its stability. Now we'll be discussing about three mechanisms today. The rest will be discussed in our lecture of aircraft stability and flight controls. Now the things that we'll be discussing will be about the dihedral, the horizontal stabilizer, and the vertical stabilizer. Okay, first of all, the dihedral. Okay. Now the dihedral refers to the angle which is there between the wings. Now the wing isn't exactly straight. There's a small angle. You see when the plane comes back into view. It's actually shaped to the shape of a V, right? And this is exaggerated. Actually, it's much less than that. But there is an angle. It's not straight. Now this dihedral helps the plane to achieve stability. This is how it works. Now say that the plane accidentally bangs towards one edge, right? If it bangs, this means that the plane will start moving to the left direction, basically your left direction. In this case, wind will start coming and hit on the right hand side of the wing, right? Your right hand side, okay? This will mean that there will be a force acting on that wing because all of that airflow is coming and hitting on it. And this will correct the airflow. This will correct the airplane. So that's the function of the dihedral. Now if you take a look at this, again you can see that the wings aren't straight. You can see the horizontal stabilizer at the back. You can see that is straight, but the wing is not. Okay? So that is called the dihedral. Right, the second one, the horizontal stabilizers. Now the horizontal stabilizer is shown in blue on your right hand side. So this is what the horizontal stabilizer actually does. If the plane accidentally pitches upwards, that's called pitching. If the plane's nose moves upwards, it's called pitching basically. So in this case, if the plane pitches upwards, wind will come and hit on the airfoil like this, right? But remember that, please note that the airflow will be diverted because of this horizontal stabilizer, because it's angled. And because of this, there will be an angle, right? And this will be a positive angle of attack. Now we discussed about angle of attack, right? It doesn't have to be a wing, okay? Even if it's the chord line of the horizontal stabilizer, still it can be considered as an angle of attack. I told you that angle of attack is the angle between the relative airflow and the chord, right? Not the airflow which is coming. But we know that this airflow and this, which is the relative airflow, are both parallel. So therefore you can consider that angle similar to the relative, equal to the relative to the angle of attack. Now take a look at this graph which we talked about earlier. I told you when the angle of attack increases, the coefficient of lift increases, okay? Basically the lift increases. So this means that because that there's a positive angle of attack on the horizontal stabilizer, there will be a lift acting on it. This will cause it to stabilize. Also note that in the case where the plane pitches downwards, then there will be a negative angle of attack. Now note that when the angle of attack goes to the left of the zero, basically into the negative side, the coefficient of lift decreases. The lift decreases basically. This means that there will be a force acting downwards and which will correct the plane again. Right, so that's basically how the horizontal stabilizers work to stabilize the aircraft. Let's talk about the vertical stabilizer. The vertical stabilizer acts like this. If the plane accidentally yaws, now yaw is basically considered as the plane turning about its vertical axis, but don't think of it like that. We'll talk about that later in our third lecture. But if the plane turns like this, the airflow will be coming like this, and air will start hitting on the vertical stabilizer. The vertical stabilizer is the part which is shown in let's say a bluish greenish color, right? So because of this, again, there will be a positive angle of attack, right? Again, we have to consider the relative airflow, but we know that these two airflows are parallel. So because of that, there will be a positive angle of attack. Now again, by the graph, we know that when there's a positive angle of attack, there will be a force, a lift basically, and this will correct the plane. And the same thing will act in the other direction, but vice versa, with a negative angle of attack. Okay, now we are on to our final part of our lecture, which will be on control surfaces. Now, control surfaces are basically defined as movable surfaces which can be used to maneuver the plane. Now, if you go back to the beginning of the video, you will see that I showed you a picture of the parts of the plane, right? Now, in that picture, you can see that there are some parts which are colored, right? So there were, as I remember, the elevator was colored. Then there was another part called the rudder, which was colored. Then the flaps were colored and the ailerons were colored. Now all of these are control surfaces, right? So in this lecture, we'll be talking about elevators, rudders, ailerons, and flaps. Okay. Now elevator is connected to the end of the horizontal stabilizer. So this is how the elevator works. Now when the elevator is pushed down, the airflow will come and bend. It will divert because of that position. And because of this, there will be a positive angle of attack with the relative airflow. Well, the relative airflow because the relative airflow and the airflow coming towards the elevator are parallel. And because of this, again by the same graph, there will be a higher lift acting on the elevator, mind you. This acts on the elevator. This tries to pull the elevator upwards. It creates a lift. Now this means, the elevator is attached to the horizontal stabilizer, right? And the horizontal stabilizer is attached to the back of the plane. So this means when the elevator tries to move upwards, the entire back of the plane will try to move upwards, meaning that the plane will try to move downwards. So this is essentially what the elevator does. Okay, so this is a model of a plane, of a Cessna 172 actually. So if you take a look at on your right hand side, you'll see the elevators in motion. Okay, give me a minute. Right, so when the elevator moves upwards, the plane will pitch up. When the elevator moves upwards, the plane will pitch up. And when the elevator moves downwards, the plane will restore its balance. Okay, those are the elevators. Now the rudders. This is an image of the. If you look from the top of the plane, this is what you'll see. Okay, so the blue color. Basically, this isn't a very good diagram. Okay, but it's just so you guys can understand it. So this the blue color rectangle, you can see the large rectangle is the horizontal stabilizer, and the very thin one is the vertical stabilizer and the rudder. So this is what happens when the rudder is moved like that. The airflow will be diverted. Because of this, there will be a positive angle of attack, in this case a positive angle of attack, with the relative airflow, right? And because of this, again, it's the same principle basically. There will be higher lifts acting on the rudder, and this will cause the rudder to divert, in this case in the upward direction. This will cause the vertical stabilizer also to have a force on the same direction, and this will cause the entire plane a force, which will cause the entire plane a force in the same direction. Okay, so this is how the rudders will look on a real life plane. When it moves in one direction, the plane moves in the other, and moves in the other direction, the plane will correct itself like that. So you can understand that throughout this lecture I've been talking about angle of attack and how important it is to understand it. Okay, so basically when you have a positive angle of attack, you usually have a higher lift, and when you have a negative one relative to the relative airflow, you have a lower lift. Okay, so this is the principle in which the horizontal stabilizer, the vertical stabilizer, the elevators and the rudders, and even the ailerons, which we'll discuss next, function on. Now the aileron is just like how the elevator and rudders work, but in this case the ailerons are positioned on either side of the wings. Okay, now what happens is one aileron moves downwards and one aileron moves upwards. This means that there will be a force acting downwards on one side of the one side of the wing, and upwards on the other side of the wing. This will cause the plane to roll. We call it roll. Okay, you'll see why. So in this case, if you take a look at this video, when the left side moves downwards and the right side moves upwards, the plane turns, and when it moves in the other direction, it corrects itself, right? So this happens in the other way as well. Okay, when it wants to turn to the right hand side, it turns as you saw it. But when it wants to turn to the left hand side, the right aileron will move downwards, the left aileron will move upwards, causing it to roll. Fine, that's the aileron. Okay, the last one, the flaps. Now flaps are basically, you can't exactly say that it's a control surface. Okay, it's actually a high lift device. It is something which is used to increase the lift. So this is what basically happens. Now when the flap is deployed, like shown, the airflow which moves down will move like that, and the airflow moving above will move like that. Now because of the flap, you will actually be increasing that distance d2, which we talked about, which means that the airflow moving above needs to move a much greater distance than the airflow moving below. This translates to a faster speed of the airflow moving above, creating a lower pressure, increasing the lift. So that's basically what the flaps are for. So this is what the flaps look like in a real life plane. It moves up and down. So take a look at it one more time. The flaps can be deployed. It just moves up, and when you want to bring it back to the normal level, they can be brought up. Right. So that's it. So that was the basics of those are the basic fundamentals of aerodynamics. And in the next lecture, we'll be discussing about aircraft engines and power systems. So in the next lecture, we'll be talking about the various types of aircraft engines. We'll be discussing about 4 types actually. The turbojet engine, the turbofan engine, the turboprop engine, and the piston engine. All types of engines which are used even now in aircrafts. And we'll also talk about 2 basic fundamental principles of thermodynamics, which are Charles' law and Boyle's law, and how engineers use these 2 principles to generate thrust within the engine. And finally, we'll also give a few examples for various aircrafts which utilize various types of engines. Right, so with that being said, this will be the conclusion of our first lecture. Please check out the second lecture to learn more about aircrafts. Thank you.